Okay, right. So that part tells us how to refer the table and get the values. So now, generally, if you take general problems are not in terms of standard normal variable. So they are in terms of general normal variable. I mean, mu can be something, sigma can be something else. But we have table only for standard normal. So to refer the table, we have to transfer any normal variable to standard normal variable. So next we are going to look at how we do the conversion and take down this page. Generally, but after that, generally, normal probability problems will be based on generally normal probability problems will be based on general normal variable will be based on general normal variable will be based on general normal variable. But table is available for standard normal variable. But table is available for standard normal variable. Therefore, we need to convert the general normal variable. We need to convert the general normal variable into standard normal variable. For this purpose, the following result is useful. The following result is useful. Following result is useful. So this is the result. So what does that say? If this, then if X follows normal distribution with mean mu, standard deviation sigma, then X minus mu. What is mu? Mu is the mean of this variable, mu, over sigma. What is this sigma? That is the standard deviation of this variable. X minus mu over sigma will follow normal 0, 1. Normal 0, 1 means that is the standard. If that, then this. So now see, original one is general normal. Mu can be any real value, sigma can be any positive value. Now on this X, we have done a process, right? On this X, we have done a process. When you do that process, it will be transferred to standard normal. So on this X, what is the process we have done? Subtract mean. What is that? That is the mean of this variable. From X, subtract its mean, divide by its sigma, then you can transfer any general normal variable to standard normal variable. Just Subtract mean, divide by sigma will transfer any general normal variable to standard normal variable. Let's write subtract mean, divide by sigma. Process එක බලන්න මෙතනට ආවේ කොහොමද? X minus mu over sigma. What is mu? Mu is the mean of this variable. What is sigma? Sigma is the standard deviation of this. Process එක done. Okay, so we'll see some examples. One by one we'll take. So first we'll take this. First one, X. Probability 2 less than X. Reset name X. X less than 3. Probability 2 less than X less than 3. Colon X follows normal 2, 4. So this 2 is the mean. This is the mean of this variable. O is the standard deviation of this variable. So they're asking us to find that probability. There we have X. So that means it is the general normal variable. So first one, probability 2 less than X less than 3 colon X follows normal. So now from this we can identify that the mean value is 2, standard deviation value is 4. So now X is a general normal variable given. We asked to find this probability, so we need to transfer this to the standard normal. So transfer කරන්නේ මොකක්ද කොහොමද කියලා ගන්න. Subtract mean divide by sigma. So that's the process. So that process should be done for all the terms inside the bracket. I know you have to do that process to all the terms inside the bracket. So we'll do the process. Probability, right? 2. Now do the process for this. Subtract mean, divide by sigma, right? So process done for this. Less than X. Okay. Do the process. So minus 2 divide by 4. Subtract mean, divide by sigma. Done for this. Then less than 3. Do the process. Subtract mean, divide by sigma. So now probability 2 minus 2, 0, 0 over 4. So that is 0. Less than. Now the purpose of doing this process is to convert this X into Z. So when you do the process on this X will be transferred to Z, standard normal. So instead of this, we can put Z because that's the purpose of doing this. Less than. 3 minus 2, 1 divided by 4. So that is 0.25. Now we are in the Z scale. Theoretical, but we have it just like in the last one. When you refer the table and get your value. And we're going to make right? The transferring process. Right. Okay, so you can take them up to this level after that. 30. General normal variable given. We are transferring that to standard normal. So now we are in the Z scale. Now we can draw the Z scale sketch. 0 comes in the middle. 0 we have to mark, already marked. 0.25 we have to mark. Positive value maybe somewhere there. 0.25. Above 0, below this. So we want this region. So now this region and your table region are the same. So straight away you have to refer 0.25 and get down along the x-axis. So along the leftmost column you refer 0.2 and on the top row you refer 0.5. You refer this value 0.0987. So the only new thing is that transferring any normal variable standard normal. Second one, probability x less than 6. Over x follows normal 10, 5 pair. So now we have a small difference between the previous and this. In the previous problem, inside the bracket, we had 3 pieces. Now we are having only 2 pieces. So if you have 3 pieces, you do the process for the 3 pieces. If you have just 2 pieces, do the process for the 2 pieces. Probability x, do the process. Subtract mean 10, divide by sigma 5. Done for that. Less than 6. Do the process. Subtract mean, divide by sigma. So this is probability. This becomes z now, less than -4 divided by 10. So it is minus 0.8. So let me do the rest of the part here. Now we are in the Z scale. We can draw the structure, Z scale structure. 0 comes in the middle. Minus 0.8 we have to mark. Is it less than? So we need this region. So of course you know how to refer this. 0.5 minus this part. 0.8 you refer, so you get this particular. 0.5 minus 0.8 you refer and subtract. 0.80 if you refer 2881. 0.2881. You have your calculation. One. Third one, probability 2 less than x less than 6. X values normal with 3 and 4 here. So now this one has 3 pieces. So we do the process for the 3 pieces. It's very easy once you get used to the process. So probability 2 subtract mean divide by sigma, right? So now see, we have already done 2 problems. So in all the problem, x when you do the process, it goes to z. So you don't have to write and show x minus that over this, right? Straight away, when you transfer x, you can put it as z because anyway in the next step you are going to write it as z, right? So without saying x minus that over this, just say x when you transfer goes to z. One shot you can write 6 minus mean divided by sigma. Probability. So here we get minus 0.25 less than z less than, here it is 3.75. We are in the z scale, so we can draw the z scale sketch. So let me draw there. Zero here, minus 0.25, 0.75. So we need this region. So you know how to get this. 0.25 you refer, 0.987. 0.75 you refer, and at 0.75 if you refer it is 75246. 27. Bad order. Next one, 4, 7. 1. Probability 4 less than x less than 7, and with x values 1, 2, normal 1 positive. General normal. So first we need to transfer this to standard normal. 4 subtract 1 divide by x. When you transfer goes to z. 7 minus 1 normal. So probability 3 over 4.75 less than z less than here is 6 over 4, 3 over 2, 1. Now we are in the z scale, so we can draw the z scale sketch. 0 comes in the middle. 0.75 we have to mark. 1.5 we have to mark. This region needed. So we know how to get this value. 1.5 you refer, 0.75 you refer, subtract it. 1.5, 43.32. Minus 0.75, 0.27. You subtract. Last example. Probability 1 less than x less than 5, and x values normal with 8 and 5. Probability 1 minus 8 over 5 less than z, 5 minus 8 over 5. Probability, this is minus 7 now minus 1.4 z. This is minus 3 over 5 is 0.6. We are in the z scale. You can draw the z scale sketch. Both are negative values. 1.4 maybe somewhere there. 0.6 maybe somewhere here. We want the in-between reason. 1.6 you refer, 0.6 you refer. Sorry, 1.4. 1.4 you refer, 0.6 you refer, subtract. So now we know how to transfer and refer. That's all we have to know for going for the practical problems. We go into the practical. Let's go. Problem detail. Take it together and we don't have to write this problem. Overload the other one. LMS එක දාලා තියෙන problem sheet එකේ තියෙනවා. චුට්ටක් check කරන්න. first problem එක maybe somewhere in the middle. What is the problem number? I didn't know. 15. So this is in your problem sheet. Question number. Sorry. Okay. ඒ මොන මොකක් කරේ එකක් 9,000 there, right? ඊට පස්සේ මම මේක short කරන්න. දැන් අපි හදනකොට right? Right. So now when you read these types of problems, right, you have to first identify what is the variable they are talking about. Because we will be right when you write probability, you will be writing like PR X greater than something or PR X less than something, right? So you will be writing an X. So that X will be the variable. So first we have to identify what is our X in the problem. So here, experience has shown that advertising revenue of a professional newsletter is normally distributed with a mean 7,800 and standard deviation 620. Find the probability, blah, blah, they are in, right? Now from this part, can you identify what is the variable they are talking about, or what is our X here? No, variable, a mean is given, a mean of what they are talking? Advertising revenue. Advertising revenue per week, if you want, you can include, right? So here X is advertising revenue, right? So first we have to identify the variable. Advertising revenue. If you want, we can include per week, no harm. Right. Okay. X we have identified. Then what they say, it is normally distributed. So if something is normally distributed, then we know a way of denoting it. X follows N, mu and sigma. So do we know mu and sigma here, the parameters? Mu is the mean. Is it given? Yes, it is given. Standard deviation is sigma. It is also given. So variable identified. They have mentioned that it is normally distributed. If it is normally distributed, two parameters should be there. One is mu and the other one is sigma. Have they given us? You have to check. In this case, they have given us, it is 7,800. Sigma is 620. And also it is mentioned as normally distributed. So we have a way of denoting it. We have everything, so that we can denote X. This X follows normal distribution. First we write the mean. What is it? 7,800, comma. Then we write the standard deviation square. So it is 620 square. So all the things given in these three lines, we have written it. Notation form. Okay. The variable should be identified. If the distribution is given, how many parameters have they given us the parameters? You have to identify the parameters. Then you put the notation. Okay. So now we'll see whether we can answer this arithmetic idea. Right. So X, advertising revenue. What is it? Yeah. Advertising revenue per week, right? Then new identified 7,800, sigma identified 620, and we denoted it. X values normal 7,800, 620, right? Square, don't forget that. Right, so now the first part. As you read, you put down the notation for first part. Probability, weekly revenue less than 7,000. So probability, PR, weekly revenue is less than notation, 7,000. As you read, you put down the notation. Probability, weekly revenue less than 7,000. Now we have 5 minutes. So this is something similar to the problem we discussed earlier. General normal. First we have to transfer this to standard normal. X when you transfer goes to Z, 7,000. Subtract mean, divide by sigma, 600. So now probability is less than, this is 800 minus 800 divided by 620. So when you divide minus 800 by 620, you get a lengthy answer. Because those are the values we are going to refer from the table. Table maximum two decimals you can refer. The first decimal meaning second decimal. So only 2 decimal we can refer. So even though you get a lengthy answer for this, we have to properly round off to 2 decimal place and write down, because only 2 levels you can refer. So if you simplify this, you get minus 1 point. Properly rounded off, right? So anytime if you get a lengthy answer here, that's what you do. Properly round off to 2 decimal place. Now we are in the Z scale, so we draw the structure. 0 comes in the middle, minus 1.29 and less than this area needed. So of course you know how to refer this. Point 5 minus 1.2, 9 it is 40/15. So it is 0.0985. So now the second one, probability අදාළ කියවනකොට ඉන්දියාව දාන්නේ notation section. අමාරු දේවල් නෙමෙයි. Second one, probability weekly revenue more than 8,000. So as you read the question, you put down the notation. That's the question. Very probability. Okay. 8,000. Subtract mean, divide by sigma. Probability is that greater than. Here we get 200 over 620. 0.29. Again, you may be getting a lengthy answer, so 2 decimal place we properly round down. So after that, zero greater than this area wanted. 0.5 minus 0.32 you refer 0.3 1255. Third part. The third part I would have changed because what you have in the problem sheet is similar type, the greater than 9,000, greater than 8,000, greater than 9,000. Same thing, right? So I have changed it, right? So it is between 7,500 and 8,500. So first you write the smaller value, less than x, less than the larger value. Between 7,500 and 8,000. Probability 7,500 subtract 7,800, 620. X goes to Z 85, 7,800 over 620. Probability. Here you will get a negative value. Then here you will get a positive value. So then you draw the structure. 0 comes in the middle, one value negative, maybe somewhere here. other value positive, maybe somewhere there. Then you need the in-between region. So you refer the two values separately and add. Next, I will check whether it is there in the 16th winner. Two-bedroom apartment. हमारा values है ना से values है ना वो कहती 450 वगैरह ने हाँ यार अरे यार क्या पेन्ने में कहा टेन दमा विनाश कर 450 रेट टोटल वो मन जन ले नहीं कहीं इसके बाद change it to 39,000 and 3,000. And the values they got. So 39,000 standard deviation 3,500. So in the question also I have made this 45,000 35. Right. So what should be the variable or what is the variable here? If it is normal, have they given us the parameters? If so, what are the parameters? What is X? What is the mean value? What is the standard deviation value? So according to this problem, what do you think? What should be taken as a variable? Monthly? Yes. Two-bedroom apartments if you want. Monthly rent, that's the important part. So monthly rents. New, and it is given that, right, not normally distributed. They say approximately normally distributed. It doesn't matter, even if they say no, approximately normally distributed, we take it as normally distributed, right? So this is normally distributed. So two parameters needed, mu and sigma. Have they given us? Mean given 39,000. Standard deviation given 3,500. And since it is given as normally distributed, or approximately normally distributed, we can put that notation. X follows normal. Mean is 39,000. Standard deviation 3,500. We write the square, so 3,500 square. So we are asked for two questions here. Now here they are asking for proportion. Proportion keyword, probability keyword, same thing, right? So what proportion of the apartment or what probability of the apartment, same thing. Rent for more than 45,000. So more than 45,000. Second part, less than 35. So X is monthly rent. Mean value 39,000. Standard deviation 3,500. It is given that it is approximately normally distributed, so we take it as normally distributed. මේවා must. මේක තියෙනවා. පුස්තක නේද පුස්තක දෙන්නවා. No binomial දෙනකොට අපි we wrote the variable. What are the parameters? Distribution. Then we wrote the probability function. Then we started doing the problem. Right? Array process taken. Right. So first part. More than 45. So they are asking for proportion. So proportion is means probability. Probability. Rent more than 45,000. So general normal. We have to transfer this to standard normal. Probability X when you transfer goes to Z. 45,000. Subtract mean. Divide by sigma. Sigma is 35,000. Probability is that here we have 6,000 divided by 3,500. Sixty over 35, 12 over 7, 1 point something. 7.5. Two decimal place 1.7. So we are in the Z scale. We can draw the Z scale sketch now. So let me do it on the other side. So we draw the Z scale. 0 comes in the middle. 1.71 we have to mark. Greater than, so this area should be found. So from 0.5, we have to subtract this area. 1.71 if you refer. It is 4560. Got your calculator. So the second part is also similar, less than 35,000. Probability, monthly rent less than 35,000. General normal, so we have to transfer this to standard normal. It's when transferring goes to Z, 35,000. Subtract mean, divide by sigma, 3,005. Probability is less than 4,000 or 3,500, 1 point. Minus. So we are in the Z scale, so we can draw the Z scale sketch. 0 comes in the middle, 1 minus 1.14. So we know how to get it. 0.5 minus 1.14 will equal 1. That is our equation. Okay. Right. Okay. So now here, now we know any type of problem given. We know how to find the probability. Okay. We have reverse type. Now see in all the problems, the value given, we found the probability, right? More than 35,000. Less than 50,000. Value we found the probability. Or between 35,000 and 45,000, right? Value given, we found the probability. So we can have reverse problem also. Probability can be given. They will be asked us to find the value, reverse it. Right? Break. So we'll have a small break. One page. Our in the world, Okay.
Maybe you do in the open. You do. Maybe you will stay from me taking. Oh, yeah. Schedule for 29.
The next I will take this stronger. Maybe 14, take away that. 14 from the. So in this one, there are no changes, like same. So it says a bulb manufacturer states that the bulbs they produce have a mean lifetime of 1,800 hours with a standard deviation of 200 hours. If a bulb is selected at random, find the probability that it has a lifetime less than 1,006, lifetime more than 1,075. What percentage of bulbs will last for more than 1,009? Radio core, same type of problems. The last one, if the manufacturer wishes to replace 10% of the bulbs free of charge, what should be the warranty period? And the reverse problem, right? So we'll do the entire problem. So first, what is our variable? X. Lifetime, right? Lifetime of bulbs or lifetime, right? Is it normally distributed? Not given. But when we start off, I gave you a list of words and a list of variables. You have to know that they are normally the lifetime, income, expenditure, marks. So those are normally distributed variables. So here lifetime is a normally distributed variable. We have to know that. A lifetime, marks, whatever, we have to know. Even if it is not given, we have to take it as normal. Right. Then mean given, standard deviation given. Okay. So we define the variable first. X lifetime. Lifetime of bulbs, give a Russian average. So if you want, you can drop that. Mean given 1,800. Standard deviation given 200. And we know that this is a normally distributed variable. So we can write X follows normal 1,800, 200 here. Less than 1,006, more than 1,750, more than 1,009, 10%. So now we'll see how to answer. The first three are normal ordinary problems. Lifetime, view 1,800, standard deviation 200. This X follows normal 1,008, 200 square. So now we can answer the question. So first part. What is the probability of more than 1,600? Selected. What is the find the probability that it has a lifetime less than 1,006? So as you read, you write down probability PR lifetime X less than 1,000. Probability lifetime less than 1,000. General normal. We have to transfer this to standard normal. 1,600. Subtract mean divided by sigma. So probability is that less than -1. We are in the Z scale. We can draw the Z scale sketch. 0 comes in the middle. -1 we have to mark. So less than this area needed. 0.5 minus this area. 1, 0, 0 if you refer. 34, 30. So it is 0.1587. So second part, it has a lifetime more than 1,750. Lifetime more than 1,750. Probability of lifetime more than 1,750. General normal. So we have to transfer this to standard normal. 1,750 minus 1,080. So when you simplify, probability is at greater than. Here you get -50 divided by 200, so it is -0.25. Now we are in the Z scale, so we can draw the Z scale sketch. 0 comes in the middle. -1.25 we have to mark, maybe somewhere there. Right, so we want about this region. So 0.25 area, you can refer to that, you add point. Zero point 0.0987. So it is 0.598. So this highlighted part, you can refer 0.25, you refer from the table, that is 0.975, 0.0987, plus this area, 0.5. Third part, what percentage of bulbs will last more than 1900? So they are asking for the percentage value. So even if they ask for percentage value, you have to first get the probability and then multiply by 100. So get the probability multiplied by 100. Third part, probability lifetime more than 1900. So probability is a 1009 minus 1008 over 200. So probability is that this is 100 over 200, which is going to give us 0.5. So what we want, draw the structure, 0 comes here, 0.5. We want above this, so this region needed. So how do we get 0.5 minus this part? How do we get this part? Refer 0.5 and get this part. So from 0.5, subtract this area. So how do we get 0.5 refer and get 1950? Right. So we got the probability, but that they are not asking for the probability, they are asking for the percentage. Multiply by 100 to get the percentage. 30.8. So now, up to now, in all the problems, see, we were given the value given, we found the probability. The last problem, probability given, we have to find the value, the reverse that. So it says, if the manufacturer wishes to replace 10% of the bulbs free of charge, what should be the warranty period? 10% of the bulbs is willing to replace. So when you tackle a reverse problem, first you have to draw the X scale sketch. Up to now, we were drawing the Z scale sketch. So Z scale sketch, when we draw, we set 0 here. This is Z scale. So now why we put 0 here? Because Z variables mean value is 0. So we introduce 0 here. Right? But originally when we draw the characteristic, right? We have drawn a structure like this. And here we mention like mu. Right? So same structure. If you put 0 in the middle, you are introducing the Z variables mean value here. So you call this structure Z scale structure. So if you draw the same structure, and if you write the X variables mean value here, right? X variables mean value in the middle, then it becomes X scale. So that's the difference, right? Same structure. Z variables mean value you put in the middle, then it is Z scale structure. X variables mean value if you put in the middle, that becomes the X scale structure, right? So make a X scale like a mean like 1008. So if you write 1008 here, then it is the X scale structure. Okay, right. So first we have to draw the X scale sketch because it's a reverse problem. 10% of the bulbs they are going to replace free of charge. What should be the warranty period? So we draw the X scale sketch first. X variables mean value 1008. So this is X scale. So first draw the X scale sketch. Right. Then what? Then we have to locate the point, right? They are willing to replace 10% of the bulbs. What should be the warranty period? So we locate right? Okay. So now suppose if the manufacturer says 1800 is the warranty period, 1800 is the if the manufacturer says the warranty period is 1008, then any bulb that fuses before 1008, I have to replace free of charge. Again, I have to cover. The මේටික ඔක්කොම cover කරන්න ගියාම කොච්චර area එකක් මම cover කරන්න ඕනද? 0.5 area I have to cover. Percentage wise, 50% I have to cover. ඒ කියන්නේ මම 1008 use 50% of the bulbs I have to replace free of charge. Now suppose I'm giving a value above 1008. එතකොට මේ හරිය එකක් ගත්තොත් then I have to cover more than 50%. 60%, 70% විතර cover කරන්න වෙයි. So but they are willing to replace only 10% of the bulb. Then I'm මෙහා කොතනද ඉන්න ඕන? Should it be a value above 1008 or should it be a value below 1008? It should be a value below 1008. May hariya value එකක් වෙනවා. Value we don't know. So first you have to draw the X scale sketch and you have to locate the point correctly. මේ පැත්තේ තියන්න ඕන එකට මේ පැත්තේ ගත්තොත් final answer will be a definitely wrong answer. අරනේ ඒක හරියට locate කරගන්න ඕන. Okay. Right. So first we have to locate. So we draw the X scale sketch and we locate. Right. So let me draw. 1008. Right. This is X scale. So now I have to locate. So we now identify it should be somewhere here. Right. Value we don't know. So we'll say A. A is the warranty period. So if we say A is the warranty period, then any bulb that fuses before A hours, we have to replace free of charge. So that means we have to cover only this portion. That portion is given. How much? 10%. 10% now. Probability wise, it will be 0.10. Now the problem becomes find this point such that this area is 0.1. Now the problem becomes find this point A such that this area is 0.1. Right? So draw the X scale structure, locate the point. Then whatever the area you have highlighted here, put in the mathematical form. Then me highlight කරපු area එක මට අර PRX less than more than අන්න ඒ විදිහට කියන්න බලන්න. Whatever the area highlighted here, you have to write down as a mathematical expression. මේක කොහොමද ලියන්න පුළුවන්? Probability X. Highlight कर देना कोई मत less than A equal 0.1. Right? So 3 steps. Draw the scale sketch. Locate the point. Whatever the area highlighted, write down in the mathematical form. So now this is general. So we have to transfer this to standard. So we'll transfer this next step. Probability. X when you transfer goes to Z. A. Subtract mean. Divide by sigma. So we have transferred this into Z scale, but probability doesn't change. Take the 0.1 minus. Right? General normal. So we have transferred to standard normal. The Samani Prashna standard normal later when you after transferring standard into standard normal, we draw the Z scale sketch. So we draw the Z scale sketch. Now this is Z scale. ඊට පස්සේ මොකද කරන්නේ මෙතන නිකන් 1.2 2.1 0.19 වගේ වැලියු එකක් එන්නේ. ඒතකොට ඊට පස්සේ මේ වැලියු එක අපි ලොකේට් කරා මෙතන. That's what we need normally, right? Now we have to locate this point. දැන් මේක ලොකේට් කරන්න බෑ මොකද ඒකක් තියලා ඒ මොකක්ද කියලා we don't know, right? Okay. Now what is this value? This is the transferred value of this A. නේද? ඒක transfer කරාමනේ මේක ආවේ convert කරාම. Right? Originally where was A? A was on the left side. So this is the transferred value. Over transfer karanakote, like left side values will be transferred to left side. Right side values will be transferred to right side. එහෙම තමයි යන්නේ මේ set එකම යන්නේ මේ පැත්තට. මේ set එකම යන්නේ මේ පැත්තට. Right? So if in the X scale, left side values will be transferred to Z scale left side. Right side X scale values will be transferred to right side. Now, since originally A was on the left side, this transferred value also will lie on the same side. May පැත්තේ left na, අර පැත්තේ left. ඒ කියන්නේ මෙයා ඉන්නේ. Right? So left side values will be transferred to left side, right side values will be transferred to right side. මේම කවදාකවත් cross වෙලා යන්නේ නැහැ. Okay? Right. So this value should be here. A minus 1008 equal to 1. Is it less than this? Yani මෙන්න මේ area is 0.1. So now we know this tail area is 0.1, but in our table, this tail area is not given. 0 to whatever the level, this type of areas are given. So if this is 0.1, this will be 0.4000. Right? If this is 0.1, this area will be 0.4000. So these are the types of area given in your table, in the middle part of the table. දැන් බලන්න ඕනේ ඔන්න ඔය 0.4 ඔය දේ තියෙන. So this is your table. So in the table, 0 to whatever the level given, the highlighted areas are given. So now we have identified the middle portion is 0.4. The 0.4 may matter table trace because values are in order. 38, 39, 39, 39, 39, 39, 39, 40. Right. We are looking for 0.4000. If we have that value, we can prefer. If we don't have that value, then there will be a value which is lower and there will be a value which is higher. The closest value. If the exact value what we are looking for is not there, then we go for the closest value. So what are the two values we have? 3997 is there. 4015 is there. We are looking for 0.4000. The close. We are close. Now you see under what reference this value is given. The value 1.2. Value make a win on a 1.28. If it is on the right side now, right? These are given for the right side, plus right side. But our value is on the left side. May පැත්තේ මේ area එක තියෙන්න මෙතන 1.28 නම් මේ පැත්තේ තියෙන්න it should be minus 1.28. ඇයි negative නේ? බලුවා. සෙලක් අදින් දාලා. So the table says this point should be minus 1.28. So we are talking about the same point in two different ways. Table says this should be minus 1.28. Our working says this point should be a minus 1008 over 200. Come point and this should be equivalent to that. Equate karana. So a minus 1800 over 200 equals minus 1.28. So we need to evaluate this A. So A equals 1800 minus 1.28. So if we simplify 1540. So if the manufacturer says the warranty period is 1544 hours, then he has to repay 10%. Exactly 10 name. I have another 0.4 almost 10%. Okay, so that's the process for reverse type problems, right? First, draw the scale sketch, locate the point, highlight the area given condition. Highlight the area, whatever the area highlighted, you write down in the mathematical form. That will be in terms of general normal, transfer, redraw the structure, locate the point, reverse prefer, equate the points. Now you don't have any class name. That's it. Reverse type. This problem is not there. This problem is not there. So we take down this and both are reverse type problem. After an examination, mean and the standard deviation of marks were observed to be 65 and 15 respectively. If 5% of the students got distinctions, what is the minimum mark for a distinction? If 12% of the students fail the examination, what is the maximum mark for failing? So first we have to define the variable. So here it is marks. They haven't mentioned that it is normally distributed. Marks is a normally distributed variable. We have to. Mean given, mu given 65. Standard deviation given 15. But we know this is a normal variable. So its values normal. Mean is 65, standard deviation is 15, so 15. So whatever given in the paragraph, I have noted down. So now first part. If 5% of the students got distinction, what is the minimum mark for a distinction? Right, at the point now, 75 is the minimum, right? Okay. So it's a reverse problem. 5% got distinction. What is the minimum mark for a distinction? So a reverse problem. Probability given, we have to find the value. So we'll draw the structure. X scale structure. X. $65, mean of the X variable. Right. So now we have to locate 5% got distinction. So we'll say the minimum of the 65 in the important component. If 65 is the minimum mark for a distinction, anyone who gets above 65 will be offered with a distinction. So that means we have to cover this whole region. 50% of the students will get distinction if the minimum mark is 65. 50% they get distinction. But they say only 5% are getting this. Therefore, they know value. Are you locate? So it should be a value somewhere here. The value, we don't know. So we'll take that thing. So if A is the minimum mark for a distinction, anyone who gets above A will be offered with the distinction. It says 5% are getting distinctions, so 0.0. X scale structure drawn, point located. Now, whatever the area highlighted, condition right? Whatever the area highlighted, you write down in the mathematical form. Probability X more than A is 0.05. So this is X scale. So next what we do, we transfer this to standard normal probabilities. We say greater than A minus 65 over 15 equals 0.05. Probability right. Now we are in the Z scale. We have to draw the Z scale sketch now. So we'll draw the Z scale sketch. 0 comes in the Z scale. Now we have to locate this point. This is the transferred value of this A. A was originally on the left right side. So the transferred value also will lie on the same side. A minus 65 over 55. Is that greater than? So this area is 0.0. If this area is 0.05, this would be 0.4500. So why are we finding that? Because those are the areas we have in our table in the middle part of our table. Then බලන්න ඕන මේ 4500 where we get 4500. We have 43, 43, 43, 44, 42, 44. 4500 we are looking for. So the two values we have. Lower value is 44.95. Higher value is 45.01. Then we go for the closest value. Same distance. So in that case, you take the average value. You can't say this is closer or this is closer. So you have to take the average. So if you go for this value, what is the reverse reference? 1.64. If you go for this one, what is the reference value? 1.65. You have to take the average of those two, right? Because the two values are the same distance. Right? Close you select that. If both are the same distance, you take the average. If you go for this, 1.64. If you go for this, 1.65, you take the average of those two. The table says this will be 1.64 plus 1.65 divided by 2. So that is 1.645. When both the values are the same distance, you take the average. So 1.645. Now you can increase this and that. So A minus 65 over 15 equals 1.645. So here I will introduce a minus sign because this is a value on the right side, so no need. So now you rearrange and get your A value. 65 plus 15 times 1.6. So what is the value again? Some 80. 20. 65 when you add
89.
89. 89 point. Right. So they are asking us what is the minimum mark for a distinction. Now the calculation says 89.675. So 18 I'm not counting off. 89.675 means you need bit more than 89 marks. Either it will be 89 marks or you will be given 90 marks. Point and then right. So this says you need bit more than 89. 89 got to madi. 90 got to okay, you are. So minimum mark for A grade is 90. Then 6. 89.6 in the round mark you get 90, but I'm not talking about rounding mark. Even if I get the answer as 89.15, still it will be 90. I make again. You need bit more than 89. 89 madi. 89 90 is the minimum, right? So not rounding. So minimum mark for it. Minimum mark for a distinction is always 12% fail the exam. What is the maximum mark for failing? If 40 is the pass mark, maximum mark for failing will be 40 pass mark now. Maximum mark for failing 39, 39, right? So let's see. Reverse problem. Probability given, we asked to find the value. So we have to draw the structure. X scale structure. 65 X. Right. So failing. If 65 is the pass mark, then 50% of the students will fail. If 65 is the pass mark, 50% will fail. If it will be more than 65, the marks is more than 65, then more than 50% will fail. They say only 12% fail. Evan, where should the marks be? Smaller than 65 or larger than 65? Smaller than. So it should be on the left. So correctly locate the correct. That is the important part here. The idea, we don't know. So we'll take this as B because for the first part we use A. So A done. B. So if B is the pass mark, anyone who gets below B will be failing. So what percent fail? 12% fail. Now we have to find this point such that this area is 0.1. Now, whatever the area highlighted, we have to write down in the mathematical form. So probability X less than B equals 0.12. General normal. We have to transfer this to standard normal. Probability is that then B minus 65 over 50 equal 0.1. Now we have to locate this one. B was originally on the left side. That is the transferred value. So the transferred value also lie on the same side. B minus 65 over less than. So this area 0.12. If this is 0.12, this part would be 0.3800. 3800. Number no, 3800 where we get. In the middle part of the table, where do we get this 3800? So 3800. 3790, 3810. 3800 is not there, so we go for the closest value. Both are at the same distance. Closest you choose that. 48 no issue, right? You go for the closest. Make a closest net. Both are at the same distance. So like earlier case, you take the average. This one, 1.17. This is 1.18. So you take the average of those two values. So now the table says this point should be minus because it's on the left side. 1.17 plus 1.18 divided by, we take the average of the two. So that is 1.175. We are talking about the same point in two different ways. Our working says it should be this. Table says this should be that. So this and that should be that. Minus the other granny. Now we equate the two values. B minus 65 over 15 minus 1.17. So B equals 65 minus 15 into 1.17. Point
75.
what is it? Right. So this says you need bit more than 47. So 47 got Madi. 48 got through. Maximum mark for failing is 47. Okay, එන්න පුළුවන්.
maximum අමාරු ප්‍රශ්න තමයි ඔක.
රිවර්ස්. ඒක දෙන්නේ අමාරු නෑ අර process එක දන්නවා. So that is probably. Timetable. Assignment එකක් දෙන්න. එහෙමට දාලා තිබ්බද කොහොමද? ඒ classes ගොඩක් ඉඳලා දැන් පැටලිලා තියෙන කොයි class එකකට දුන්නේ කියලා. අවර එකක් තියෙනවා ඒක බලාගෙන අරක බලන්න. I was stressing බලාගෙන එක AC section එක. තව එකක් තියෙනවා criteria. So ඒක if you know how to add how to divide ඒ ටික කරන්න. පොඩි දෙයක් තියෙන process එකක් තියෙන process. ඒක අමාරුම එක තමයි probability එක. probability එක පොඩ්ඩක් බලන්න. අනිත් ටික කරාම probability එක නෑ ස්කිප් කරන්න එපා. හැමදේම කරන්න මොකද ඒ වෙලාවේ ගාන කොතන හරි පොඩ්ඩක් ඉර වුණොත් වෙන ගානක් හදන්න පුළුවන් ඔබට choice එකක් තිබ්බා. මිස් කරලා ගියාම අපි කියමුකෝ ස්කිප් කරලා ගියාම අර ස්කිප් කරපු එක මාර ලීසි ගානක් වෙයි. සාමාන්‍යයෙන්ම නෙමෙයි මාර ලීසි ගානක් එකේ හදාගන්න බෑ මොකද බලලා නැහැ. එහෙනම් හැම එකම බලාගෙන යන්න එතන ගිහලා you decide which one is easy for you to. එයා මම මේක දාන්නම් SMS එකට අරක්යි කියලා කෝඩ් කරලා. ඔයාලට quiz එකක් වගේ හොඳද නැත්නම් written එකක් හොඳද? assignment එක. quiz එක ලෑජි. එකක්. එහෙමයි assignment එකක් නෙමෙයි. ඒවඩා ඉඳලා නිකන් take home එකක් වගේ හොඳයි නේද? I don't mind. Individually, you have to submit. I don't mind. You can get together, work the problem, but when you substitute, it should be your own work. I don't know. I can section you assignment whatever you don't know, you have to understand that you can get together, work, but when you submit your individual. I have to check with them. I think go there as a fraction and a fraction they got. Even data like normal you can sit down and you can work out 1 hour. You can teach. Our papers like last time exemption negative money maker. 16 16A weekday weekend a ඕන මේක මගේ paper එක යන්නේ. ඒකට model එක බලා ගන්න ඕන නම් ඒක තරම් බලන්න. 16A B C D එකට නම් තාම තියෙන්නේ නැහැ. A B C ඒගොල්ලන්ගේ papers weekday or weekend කොහොමද එන්නේ මගේ paper. model එක බලා ගන්න ඕන අර structure එක